The change between doing applications in the traditional sense, mainframe-oriented or mainframe-centric as we might refer to it, to a more distributed application, a client-server is the buzzword today, distributed application, is a dramatic change upon most IS organizations, ours included. We don't necessarily have all the skills and all the tools yet, and it's quite a change to understand that parts of the application may in fact be resident on the personal computer, parts of the application may in fact be resident on the mainframe. What we're finding today is that we're obtaining more and more tools to make that transition easier. Our users get quite excited when we show them some of the new applications that we've been doing. Practical experience has shown that it's very easy to go to a user, do an application on a PC, in particular Macintosh, and take that application, show it to them immediately, and just watch their eyes. There's tremendous excitement about it. They see a change in what we're providing for them. They also see the opportunity for them to be able to better take control of their own business, understand their own data. We have many examples of applications that we've produced and custom developed for our users. When the first time that we showed the application to them, users' responses were, "I can't believe it. I can't believe you did it that fast. I can't believe that I can get to things in such a manner. It's really not that hard."
AppMaker's a tool for making Macintosh applications. Instead of typing hundreds or thousands of lines of source code, you point and click to tell the computer the results you want. Then AppMaker generates source code for you. When you create a new application with AppMaker, you get the standard Apple menu, a file menu, and an edit menu. To create a new menu, choose New Menu, and type the title. We'll call this Options. Then type the menu items. We'll have a font menu, and we'll add a dividing line. We'll add more menu items later. To create a new dialog, first select Dialogs, and choose New Dialog, and type a name for it. We'll call this one Communicate. In this dialog, we'll have a pair of icons for choosing the port. Let's first type in the port text, and then create a modem icon, and select a printer icon. At runtime, when you click on one of these icons, it will highlight to indicate which port you've selected. Now let's create a pop-up menu for choosing a speed. Let's title it Speed. And let's make a pair of radio buttons for choosing the type of dialing. So first we'll type in the text dialing. Then we'll create one button for touch tone. And we'll create one for rotary. And finally, let's create a box which will hold a list of addresses. Type in the text for addresses, and create a scrolling list box. After you've designed your user interface, your menus, windows, and dialog, you're ready to generate code. You can choose from among a number of languages. These include object-oriented programming languages with a Think class library in C or Pascal, or traditional in Pascal in either C or MPW. Let's choose Think C for this application. We generate the code, and to save time, we'll fast forward through this sequence, generate the code, and compile and link the application. When the application comes up, you see the standard Apple menu, the File menu, the Edit menu, and the Options menu. Let's select the Communicate dialog we created. Here are the modem and printer icons. When you click one, it highlights. Choose a speed from the pop-up menu, or click on a radio button to choose touch tone or rotary, or select from a list of addresses. This application, without typing a single line of code, took less than 10 minutes to design and compile and link it without error. The result here today, a working application. We're going to build a simple calculator with HyperCard using its built-in programming capabilities. First, let's create a field. This is an object that can hold text or numbers. It can be moved anywhere or be resized. This field will hold our input data. Let's make it this size and put it here. Now, the way HyperCard works is that any object has associated properties and attributes. Now, to get to them, you double-click on the object like this. Now let's make this field a rectangle. And let's give it a font of Garamond 24 point. Over here you can see how it's going to look. So let's make it a little larger, Garamond 36 point. Now let's go back and make the field a little smaller. To make another field, the one that will hold our output data, we'll click on the field, copy, and we'll paste the copy over here. Now let's give these fields some names. This first field we're going to call Input. And this other field we'll call Output. Now let's create two more fields where we'll put some titles. Let's call this field Input Title and make it a rectangle. And give it a font of Garamond 24 point. And let's copy and paste this field over here. Now we're ready to type some title text in. Let's type Fahrenheit over here. And on the other field, let's type Celsius. Now, we're going to make one more change. I don't like the boxes around these title fields, so I'm going to get rid of them. So I'll make this field transparent and make this one as well. Now let's create one more object, a button. Let's double-click on it, give it a name. Let's call it Calculate, and make sure it highlights when you press it. And let's create a script for this button, which is a program using HyperCard's English-like programming language, HyperTalk, that's activated when you press on the button. The first line we'll type in is Get Card Field Input, and the second line is put it minus 32 times 5/9 into card field output, which is the formula for converting Fahrenheit to Celsius. Now we're ready to test our program, so let's put in the number 100, press the Calculate button, and over here we get the converted Celsius temperature. Let's try it again with 32. Press Calculate, and we get 0. Finally, if we want to add something else like a second button that will compute square root, we can easily do that by adding a couple of more lines in HyperTalk. And if we'd like to add a title to our calculator to make it look nicer, we can do so very easily. Here, we will create another transparent field for the title. Center it and make sure it's in Garamond, the correct font. Here's how easy it is to build an application in HyperCard. This is HyperGold, a HyperCard-based personnel management system. It's a front end that runs on a Macintosh and connects to a personnel database running on a VAX. Each person first identifies himself with an ID password and clicks Login. The host checks the password, makes preparations to log on, receives my request for data, and verifies the reports. My Macintosh will now receive the data, receive all the forms. Now let's review the actions you can take. Across the bottom, you will notice compensation, review, organization, status, and other information. I'll choose compensation. This retrieves the compensation information. So here we see the salary, stock, and bonus information. Here's the individual salary information, including the compensation ratio and last salary change date. Let's change someone's salary. Here's the information for Kevin Sullivan. You'll notice that his comp ratio is 98% of the industry standard. I'll change that to 100%, and the rest of Kevin's information is automatically updated. Now I need a date for when this is going to be effective. I type that in, and once I click on Approve, everything is checked, and I'm shown this screen. Over here is a place for comments, which stay with the record. And over here, I can put Post-it type notes, temporary notes that don't stay with the record. Once it's been approved, the form is forwarded to my director, who gets a chance to look at it exactly the same way. Approval's completed, and the salary change is official. Additional features include an employee bonus calculator with a variety of options. A full-featured performance review form with room for notes and comments, and an employment history page that provides access to employee status, history, and other personnel information. This was a look at HyperGold.
With over 20,000 miles of railroad track and more than 2,000 trains rolling each day, CSX is a leading international shipping company. Joe Herron is Assistant Applications Manager for CSX Technology.
Well, today you're at our new centralized way billing center. This is where we process all the customer requests for shipments of merchandise. The way we used to operate is that customers in outlying CSX locations would fax in their bills of lading or requests to various centers where clerks would then perform the data entry to get the cars moving. CSX receives approximately 10,000 pages of bills of lading a day. This is 24 hours a day, in fact. These 10,000 pages represent approximately $20 million in revenue that we're processing through here every day. So it's absolutely critical that we not lose track of one sheet of paper. What we've attempted to do here is to centralize all that activity into one location, remove the paper, that is through removing the fax machines, make it all totally electronic.
CSX conducted a thorough evaluation before choosing a development platform.
We put out bids to various vendors and systems integrators to try to do this project. We knew it was a very complex project. It would involve lots of new technology that we didn't have a lot of experience with. We really weren't very satisfied with what we got back, the technology they were using, and with the prototypes we saw. So we made a crucial decision of trying to do it ourselves. This is a truly mission-critical project. It absolutely cannot fail. Like I said, we have $20 million of revenue at risk every day.
And CSX turned to Macintosh.
We looked at various technologies, various architectures for doing this project. What we found was we put together a simple prototype on a Macintosh in about 5 minutes that did some of the things that one vendor had spent 18 months trying to do. Namely, that was to display 2 full 3270 sessions in an image on the screen simultaneously and be able to easily switch back and forth between those.
The architecture of the Macintosh made it the ideal candidate for CSX and its crucial development effort.
And we saw right away that the Macintosh was built from the ground up to be a graphics workstation. So we didn't have to do any any complicated programming to get it to that point. We could concentrate on our application at hand and not worry about all the technical details of working with graphics.
This was a project that could not fail. And for CSX, Macintosh and object programming technology met the challenge.
The entire process is improved. We get the orders in more quickly, which means the trains move more quickly. The customers get billed sooner. The bills are more accurate, so we collect our revenue sooner. And from our customer accounting side, they can resolve disputes much quicker. Prior to this project, the Macintosh had not been used as a development environment. It had been primarily a desktop publishing tool. What we've learned from this process is that it is a very rich development environment, that we can develop things very quickly, and some very powerful applications that we found very difficult to develop in some of the other environments we were using. So we are trying to standardize on the Macintosh as our graphics workstation of choice.
Here's the opening screen for ThinkC. If I want to run my program, I simply choose Run from the project menu. That compiles all my source code and libraries. It's a very fast compiler, up to 48,000 lines per minute on a Mac 2. When it's finished compiling, it runs my program. This program is a simple demo program called Bullseye. It displays a window with a bullseye graphic in it. And over here is a width menu, which will control the width of the rings in the bullseye. Okay, now I'm going to show you the fast turnaround time of ThinkC. By modifying some source code, I'll simply open up the file for editing by double-clicking on it. Now I'll change the initial width of the rings from 5 to 12. And I'll close the window. The changes are saved automatically. Now I'll select Run, and the file's quickly recompiled, and the program begins running with a newly defined ring width. Now I'll demonstrate some of ThinkC's debugging capabilities. I'll choose the debugger command from the project menu. Now my program will appear in the debugger before it starts running. In the source window on the left, the arrow indicates the next source statement to be executed. Using this source window, I can move step by step through the code at the source level. The step command will step over function calls. The in command steps into function calls. And if I want to run my program, I click on the go command. I can also suspend program execution by clicking the stop button. Now I'm going to set a breakpoint in my code to handle choices in the width menu. These diamonds on the left side indicate the executable statements in the source code. I can simply set a breakpoint by clicking on the diamond. So now when I resume my program and choose something from the width window, it actually stops at that breakpoint. The data window for the debugger is over here to the right. This is where I can examine and modify variables as my program's running. I can do that by double-clicking on a variable in the source window and choosing Copy to Data. It copies the variable over to the data window on the right, showing me the value of the variable. Here I can change the current values of the variables I'm executing by simply selecting the old value and typing in a new value. In this case, I'll simply change menu item from 4 to 1. Now when I resume execution, the program will act as if I chose 1 from the width menu. ThinkC is a great example of how Macintosh programming tools can streamline and speed up the development process. Let's start with an image of a normal spreadsheet. This is what most people think of when they think of spreadsheets. But this is a spreadsheet as well, a programmable wing spreadsheet of an executive information system for the fictional Clean Air Corporation. In order to check on the store inventory, the user clicks on the store inventory icon. We're presented with a color-coded map of the United States. Clicking on any region will allow us to have a closer look. Let's zoom in on the Northeast region. Here we can select any state or group of states with the mouse. We can make our selections by clicking on the individual states or by clicking within one of the check boxes on the right. Now, once we've made our choices, we then select the Get Data button. The resulting information is presented in a tabular fashion. Clicking on any of the column headings will sort the table in descending order based on the selected column data, and clicking on any of the rows in the table will show us an informative three-dimensional pie graph representing the designated store's inventory. Now let's click on the Return button to go back to the previous sheet. Now let's take a look at how our sales force is presently performing out in the field. By clicking on Staff Sales, we're presented with a pictorial chart of the field sales organization. Using the mouse, we can select a salesperson, so let's select Mr. Jones. As you can see, the resulting table shows the sales performance of our Mr. Jones, along with those salespersons who work for him. Similar to the inventory example, clicking on any column will sort by that column, and selecting any individual will produce a bar chart representing the selected individual's performance. Now let's return to the previous sheet and take a look behind the scenes of this Wings hyperscript application. Let's assume that Mr. Curtis has just received a big promotion and is now reporting directly to Mr. Jorgensen. We must alter the application accordingly. First, we'll use the Object tool to move an invisible button over to the right side. There's a script attached to this button that will call up detailed sales information on Mr. Curtis's picture. Now let's click on the image of Mr. Curtis and drag it up to the top of the sales chart just to the right of Mr. Jorgensen. We'll also need to bring his name up just underneath his picture. You'll notice that the blue line now runs through the front of the picture. In order to solve this problem, we need only select the picture, go to the Graph menu, and choose Bring to Front. The Wing spreadsheet is a layered environment. Now we'll go and get our invisible button, which we left in the upper right corner, and place it so the outline falls directly above the picture of Mr. Curtis. Let's make modifications to the button script. We need to edit the script to reflect the changes we made. Since Bill's received a promotion, he has 5 new people below him. Let's type their names into the appropriate function in the script. Notice that this script is very similar to HyperTalk and is very easy to program in. Now let's close the button script and save changes. Now to clean up a bit, let's select the small blue line left over from Bill's old position and press the Delete key. Now let's select the Worksheet tool from the toolbox and choose Show Toolbox from the Window menu. We're now ready to test our modifications. If we now click on Mr. Jorgensen's right-hand man, Bill Curtis, we're presented with a table showing Bill's performance, along with his new employees. We can select any of his employees and get a graph of his performance.
Hi, I'm Ann John Siracusa of Data Resource Management at Apple Computer. A typical JAD session usually includes a group of customers gathered around a table, led by a facilitator such as myself, in front of a whiteboard. The process starts with the JAD session. We should have already selected a particular functional area to help keep the meetings focused. As the facilitator of the data modeling portion, it's my job to try and discover the data requirements of that particular function. This is then translated into a data model, which consists of the objects of interest, which are also called the entities, the data about those objects, also known as the attributes, and the business rules which connect those entities together, which are depicted as relationships on the model. The model is actually done during the session, on the board, and may also be captured in Silverrun. We're also able to make use of the recent introduction of our portable, using a portable hooked up to an overhead projector. After the session's over, we print the model off the whiteboard. This original hand-drawn version is extremely helpful when trying to remember what really happened during the sessions. We can also print the model from the Silverrun case tool. We then take that model that we've developed, take it back to my office to do what we call the back room work. That's where we finish off the model, add all the final details, which may include some further customer involvement. The model I'm creating represents some marketing demographics data. I'm going to complete the model that I started during the JAD session using the Silverrun LDM tool. First, I need to create a new object or entity to capture employment forecast figures for each industry-occupation combination. I'm calling it Industry Occupation Matrix. Next, I'll add relationships to document the business rule that each combination in the matrix will represent the forecast for one industry and one occupation. Then I'll attach or link the attributes that I entered earlier into the dictionary to the new entity. These are the employment forecast figures. Finally, I specify the unique key of the new entity to consist of the combination of the key attributes of both industry and occupation. My logical design complete, I now want to generate my database model. First, I need to run an integrity check which validates certain critical data modeling rules such as key structures. Errors can be saved to a text file. When it completes without error, I can generate the model for my target DBMS. Using the Silverrun utility, I request a complete relational schema since I'll be implementing in DB2. With the relational model now generated, we scroll over to the new entity to see all of its attributes, and Silverrun has correctly propagated industry and occupation code as the foreign key attributes. I can also export any combination of information out of the dictionary into an ASCII text file for import into other applications such as Excel. Here, I open an attribute export file while in the Excel application. A new worksheet is opened, and the attribute data is dropped into individual cells. I then select the records, do a copy, and bring up a second worksheet already formatted with headers and correct column sizes. I then paste the records into this worksheet. I can use this to do mass changes, searches, etc. The last task is to generate the database definition language, or DDL statements, needed to create my database. Usually this includes several interim steps, such as redesign for performance reasons, the generation of DBMS-specific names, and other enhancements required by the target DBMS. I open my DB2 DDL, I'll give it one final check, and I can start thinking about bringing up a live database. Once the DDL is completed, we ship it up to the host, and we can create our prototype database and populate it with live data. All of this is done prior to any subsequent validation sessions. And it's the validation that's really critical to the success of any project. Validation takes place in a separate session in which we reassemble the original customer team and have them pose business questions. I can then walk through the model and show them how the structure can be navigated to support the answers to those questions. We feel, however, that a more effective way to do the validation is to have live data on a prototype database. We have a tool at our disposal that gives us the ability to do that. That tool, called the Query tool, gives us easy access to a prototype database. With it, we can create and execute live business queries using live business data. Let me show you how that works. We're going to run a query against the employment forecasts. First, I want to limit the records selected. I ask Query Tool to return all the industries from the database. Then, from the list returned, I select the 3 industries on which I will report. Within these 3 industries, I only want occupations in which the forecasted employment in the year 2000 will show 50% growth over 1986. This is declared as a constraint to return only those records in which the year 2000 employment data is 1.5 times the value of the 1986 employment. I've now defined which records I want to retrieve from the database. To finish, I simply select and drag the desired fields into the query window and run the report. Query tool formats the SQL query, sends it to the database resident on the mainframe, and returns the data. The records retrieved can then be managed at the desktop. This should give you a glimpse of how we're using the Macintosh and various case tools to design and develop databases in our multi-vendor environment.
This is the system's context diagram. The bubble in the center contains our system. The boxes are objects that the system has to deal with in the outside world, like the keypad, card reader, a cash dispenser, and a receipt dispenser. Here's a very small piece of the ATM system's data model. In this demo, we're going to concentrate on the functional support toolset, so let's close the data model. Now we're going to move down to the next level of detail in this DFD. I will click on the bubble representing the system. A child diagram comes up on the screen. Data is on the solid arrows and control information is on the dashed lines. We can view this diagram as strictly a data flow diagram, or we can view it as a control-only diagram. Now let's look inside of the control specifications for this diagram. I'm going to open up the Fast Task tool for this. This is a finite state model where we have states in the different boxes on the diagram and events and actions on the arrows, which are called transitions. This diagram shows how a system transitions from one state to another. I can translate my model into a state table or also as a state by event matrix, showing all the states of the system on the top and all the events on the left margin. Let's go back to our DFD now and change the diagram so that both the data flows and control flows are showing. Now I'm going to move further on down in this DFD's hierarchy. This brings up another level of child diagram. With this tool, there's no limit to the depth you can go. If I double-click on a sub-process bubble, you'll see that a new diagram is created for me, and the input and output data flows are propagated off the parent diagram. Let's detail our diagram further. I can use the standard Macintosh copy and paste commands available under the File menu to create additional bubbles, or their keyboard equivalents. Let's now make some space to work with. If I drag bubble number 1 up to an arrow and just touch it to the end, then the arrow sticks to it. I can move the bubble around the diagram, and the line will stay connected. I can attach text to any object by using the T icon off the palette. Clicking in the object, and then entering the name. I can get at the dictionary definition of a diagram object by just double-clicking on that object. Let's see the definition of the flow 4-digit code. This tool can be used on a network by multiple users. I can set access control for an item by hitting the Access Privileges button on this dialog. This brings up a dialog screen that has access control information. You can set privileges for your dictionary entries on an item-by-item basis. Let's go back and take another look at the dictionary. This time I'll enter my dictionary by choosing Edit Dictionary off the Dictionary menu. Here's the dictionary object list. If I enter T on the keyboard, it scrolls me down into the T's. Now let's look at the data transactions definition. It has a component and a comment section. If I want to rename, say, the 4-digit code into a 5-digit code flow, I'll find the entry, press Global Rename. I'll then type a 5 over the 4, hit OK, and this returns me to the dictionary main screen, where 5-digit code has now replaced 4-digit code. Now we are back in our flow diagram. You can see that it's renamed our data flow here and actually on all the diagrams in the system. We're now back in the Level 1 diagram. Let's look at a mini-spec for one of the processes. We're now at the mini-spec level. If you look here on the mini-spec menu, you'll see an item called Create PDL for mini-spec, that pseudocode description language. The mini-specs become the link between requirement analysis and detailed design tools in the set. Let's move on now to the next level of the ATM system's design, which is captured in the Smart Chart module. What we'll be looking at is a program structure chart for the automatic teller system. I can view the diagram with either orthogonal lines with data flows, as shown here, or with diagonal lines on them. I can change them using the Chart menu and the Style Options submenu. Now I'm going to open up a file called ATM PDL Design. This file contains all of the PDL or pseudocode description language that was created in my data flow diagram mini-specs, plus additional program logic added during design. Now if I return to my structure chart, I can move to a particular spot in the text file by simply picking a node box on the structure chart and double-clicking on it. The text editor is returned and the subprogram chosen is highlighted. Let's put this text into a 12-point font. And let's make it easier to see both windows at the same time by resizing them and lining them up side by side. The pseudocode or structured English that we see here on the left for the ATM system was used to automatically generate our structure chart. Another tool allows you to draw structure charts by hand if you want to. I can use the PDL language template to further detail my program logic, but let's assume we have completed this step. Our next step would be to build the program's source code, and we can do it right in the same file with our PDL. First, let me make this piece of completed pseudocode a legal comment in the C language. Now I will identify my language choice as C. There is support for a wide range of languages including COBOL, Pascal, Fortran, and Ada. When I pick C off the language menu, this action changes the menu under templates to be C language syntax. Now I'll put in a C function header. Notice the syntax added to the text. Let's add some more detail to our code. I'll double-click the mouse where it says statements to highlight this variable. Then let's put in an if-then-else statement. I'll go back up to my templates and pick the if-then-else construct, and our code appears. If I hit the Enter key twice, it takes me to my first variable placeholder. I just type the word true, and it types over the text. If I hit the Enter key again, it takes me to the next placeholder. I'm now building legal C code in here. I can build legal code in any of the other languages, COBOL for example, that I have templates created for. Just for fun, let's see a COBOL string statement. But let's get some more space in here because an I/O statement is a pretty long statement. And again, notice the string statement being generated in our text.
Our goal was productivity increase. So we looked at the overall process we call value chain analysis. It was being done throughout TRW, but then applied it into much further detail, which we called our leverage analysis survey, which we looked at 128 tasks and through all phases of the project, and then summarized that up to 33 areas of functionality that would require tools. So some of the interesting findings we had there is that a lot of the hype we see in the industry related to computer-aided design tools, although they're very important, our entire design, preliminary design, amounted to 4% of our total development effort. The detailed design amounted to 6%. So that my whole design effort, which we really went out to think we could get a big improvement in, even if we could get the factors of 2 that is claimed in the industry, that would still only save me 5%. Well, the key finding, I think, was that there wasn't any golden egg in one small portion. Most of the productivity increase was going to come out of the front end of the development, not the compiling and the classic back end. And with that, we concluded that we had to have this desktop engineering environment for not only the people on the project, but all the support people that support the project. So we concluded that to achieve productivity, we estimated that we could get a 37% productivity increase without reuse by instantiating a hierarchical development environment in which we used a homogeneous front end. And we selected the Mac II for doing that because it had a broad set of tools that could support all of these other activities. And then we could have an interface into whatever mini computer or other vendor's machine that we were going to use for the particular target application. Our baseline, as we looked at the development environment early on in the project, was that we would use a Unix-based workstation. And when we first had non-disclosure of the Macintosh II, we kept it as the dark horse. As time went on, we began to understand where we could really get the productivity. We concluded that we should go with the dark horse. And it's clear now that that was the correct decision for us.
McDonnell Douglas just purchased 782 Macintoshes at the Space Station Division.
Last year, we not only paid for our entire creative department installation of the Macintosh, but made a $50,000 profit.
From my Macintosh computer in my office, I can talk to NASA headquarters, connect to the Supercomputer Center down in San Diego. I can connect to any of the universities. So sitting here from my office, I can get to just about anywhere in the world.
We are set up in 30 offices across the United States with relational, multi-user, remote hooked up networks.
Literally hours are saved every day because we have that email system.
The Mac can access the host, perhaps easier than a 3270 terminal.
We can just click on a country and communicate documents directly.
I need good programming tools. Apple has good programming tools, both from their own efforts and from the efforts of third-party vendors.
We chose the Macintosh to use as our editorial storage device and navigator, thanks to HyperCard, because it is the only computer that can simply and effectively act as the front end to our video disc.
If they can't do it on the Mac, then obviously it's something that can't be done.
They are probably one of the best computer companies to work with as a third party, because they have a group of people whose job it is to make my life easy.
Used to have 10 machines before, literally 10 machines which I would watch. Right now, all I do is have to watch this one screen. It takes the place of 10 machines. Excuse me. Hello.
What we found was we put together a prototype, a simple prototype on a Macintosh in about 5 minutes that did some of the things that one vendor had spent 18 months trying to do.
We find that the Mac 2 with the photo expansion capabilities approaches the capability of our central VAX system. And that's not a game. That's real business and real impact and power.
A lot of what works in the Macintosh works because those of us that were part of the design were very interested in service organizations, particularly large consulting organizations, and we're trying to understand what they did. And to me, one of the differences, a service organization is one that it doesn't call the people it works with customers, they call them clients. They think of them as being people that they're going to have a very long-term relationship with, and they're not trying to just fix something that's wrong with them right now, but instead it's an ongoing relationship.
Well, I believe that the Macintosh design principles and guidelines, as well as the built-in toolbox layer, as well as the desktop layer, really allowed third-party software developers to create tools that were both powerful, intuitive, as well as integratable with other tools that were developed from different sources.
It's in some sense sad looking at people use other platforms. They get information onto, say, a dumb terminal, and the next thing you see is people sitting with a pencil and paper and copying numbers down and then going over to a calculator or over to another computer and then entering it in. Well, that's not the way we do things in Macintosh. I mean, we've had a facility called copy and paste from day one within the machine, within the system software.
Nice user interface isn't enough, that there has to be an enormous amount of function behind it, and although Apple doesn't emphasize it, we have the most powerful processors that are on desktop computers today. They deliver a lot of function, but by the same coin, the function is absolutely irrelevant if people can't get to it. So it's really a balanced situation where you have to have ease of use, but you also have to have power that you're getting to.
The fact that information is stored on some big brown spinning disk inside of a glass house is of interest, but to make it useful to people, to the knowledge workers in an enterprise, you've got to find a way to facilitate their obtaining the information and analyzing it. And that's the beauty of the Macintosh.
One of the things that people don't realize is that Apple itself is a large corporation that has many of the same needs from an IS, or information systems perspective, as they do. And as a result of this, we have developed solutions for ourselves using the Macintosh that makes us more productive. For example, we have integrated most of the system's platforms, whether it's IBM mainframes, IBM mini computers, DEC VAX mini computers, tandem non-stop computers, all together in such a way that the Macintosh becomes the single dashboard or the single point of entry to our users into all these different platforms.
I believe that what the Macintosh is not a computer, but a communication service.
One of the things that's absolutely great about the Macintosh is the ability to take data or information from a variety of platforms and integrate it together regardless of which system this information or data came from. For example, you can take data from DB2, which happens to be running on an IBM 3090, as well as data from a DEC VAX system, and integrate it together at the same time on the Macintosh.
First is it's designed into the system. I mean, you don't have to buy an overextended this or a super extended that to get communications. It comes with the Macintosh.
An operating system does not have to be large to be useful. some of the better ones ever done have been rather small, and they get barnacled up as you put more and more things in them without actually doing redesign. At Apple, we actually redesign periodically and re-implement so that the kernels can stay small.
The Macintosh application set, the power of the platform, can now, through the networking facilities, be directly applied to information stored in the confines of the glass house. Now, I think what's going to happen is people are going to catch on. Gee, now I can get that information out of there, and I don't have to wait for a programmer to write a new program.
I would characterize Apple as a company that was founded on the emotional sense that the world could be made a better place by changing people's relationship to their information media. And I think most of us who are at Apple, especially in the technical domain, still believe that practically religiously.
The Macintosh will play a very key role in the future of computing.
The Macintosh is known to be the most useful and most friendly personal computer in the industry. What we know our customers expect of us is a networking technology that achieves that level of usability. That's what we want to do.
It will basically empower developers. It will empower IS executives. It will empower IS users. Because what it will allow us to do is to access multi-environments from multi-vendors and present information in a multimedia way. This is the future.
As a professional consultant, we deal with a range of different customers, from government agencies, military agencies, federal agencies such as the FBI. We also deal with large Fortune 500 companies. Many of these organizations and companies are implementing executive information systems. For systems to be used in the executive suite, they have to be simple to use, and so the user interface becomes very critical. Mainframe user interfaces were not very well suited to that, and PCs and Macintoshes simplified that considerably, and the graphical user interface that's used in the Macintosh is very useful. Executives are very busy, and they often have a very limited amount of time to catch up on the key management indicators that are included in an executive information system. Graphical information is extremely important. Tabular information is still vital, but graphical information is important for being able to see trends. Because of the Macintosh user interface with the menu bar across the top, it is possible to keep track of what windows are open on the screen. It gives the executive a real easy tool for navigating between the open screens. Again, executives and analysts are all very, very busy, and to the extent that they have to stop and wait for something as opposed to being able to send off a request to a server and get that information back, that's very, very important, and that's another one of the things that you get from the increased connectivity of the Macintosh, particularly support for local area networks such as Ethernet and Token Ring. As a software developer, I found that the Macintosh is an excellent environment in which to work. Once you become familiar with the Macintosh user interface, then the richness that's in the Macintosh product is easy to use. Increasingly, we've demonstrated the EIS software on the Macintosh, and you get the sense that, yeah, this is going to be useful to me. I'm going to be able to manage my information and look at it the way that I want. We're very encouraged about potential opportunities in utilizing Macintoshes, and having mastered, if you will, both the PC environment and the Macintosh environment is a real plus, and I think that's going to give us an advantage in terms of the future.
First and foremost, at Pharos, we are very interested in the user experience. When we looked around at possible technologies to be involved with, it was very obvious how far out in front Apple really was. I think the consulting opportunities for Macintosh integration into corporations is very large. What we're seeing is, first of all, that there's much greater acceptance in MIS departments for Macintoshes now. I think they realize that the user base has spoken and that they are getting very effective use out of the Macs. Our philosophy in working with resellers has always been to develop a strategic alliance, much like a marriage, and then work together to provide a common philosophy of service and support to our mutual client.
Well, this whole area of groupware that's coming.
The fact that we introduce this type of a resource into an account is politically good for us. It puts us in the role of consultant as well. I mean, it makes us involved in what I like to call consultative selling.
For the most part, Apple has been a very strong ally throughout this. Actually, they're certainly a center post. They have the brokering relationship, if you will, to help ensure that there's integrity in a relationship.
So what you're telling me then is that the manager has the ability to...
We didn't take a short-term approach to this, and by doing that, it forced a decision process out that every time we went to do a particular job together or a project together, really we put the client first and foremost.
If I can measure the success, I can measure it by how much we really don't have to communicate. A lot of things we take for granted now, that there is going to be successful performance on both parties. There's a high degree of confidence and trust in each other, so that indeed when we do go in working together, that one side doesn't have to be checking on the other to make sure that the relationship is going properly. We're certainly proud of our growth. In 1986, there was one of us, me. 1990, there's 30 of us now. For a consulting firm that its revenues come from really horsepower of the per hour charge, that's good growth.
A lot of companies.
Of course, we couldn't have done it without, again, the relationships we've been able to develop with Apple, with the reseller community, and certainly with our clients.
After Hours Software specializes in developing customized databases and integrated systems which involve the Macintosh family of computers. We'll develop systems which involve both Macintoshes and VAXs and IBM mainframes, and we develop databases which can communicate information back and forth to provide the best solution of power and interface. The Macintosh is a great interface tool. However, there are certain situations where it's not powerful enough to handle a database, hundreds of thousands of records spread out all across the country. Developing an integrated system where you use the Macintosh as a front end to this more powerful VAX or IBM mainframe, you can actually use the interface and use all of the benefits of the Macintosh and still get the power and the flexibility on the back end of the bigger machine. We developed a system for the Los Angeles Rams that did exactly that. They had a Quantel system with dumb terminals, and it was very confusing. It had lots of features that they didn't know how to use. We implemented a similar system using a VAX with Oracle and Fourth Dimension in the Macintosh, and within a day we had trained everybody in the office, and they now can use features of the system that they said they knew existed before, but in the 2 years they had the system could never figure out how to use. It's interesting watching the evolution of the Macintosh because more now than ever, and I think more in the next couple of years than ever before, it'll be much easier to integrate Macintosh into existing corporate systems. And as easy as it is now to do this, I think the tools that are coming out that we've seen are going to make it even easier so that you'll be able to quickly and easily develop an application on the Macintosh which interfaces to all of the existing corporate systems in a two-way mode, meaning you can either pull information from those systems and also feed information back, and it will be a seamless integration with the power and the ease of use and the interface of the Macintosh and the power of the machines on the back end like a VAX and an IBM mainframe.